Okay, in this video I'm going to talk about how to use some changes to an equilibrium system to determine what the value of the equilibrium constant would be. So here we have H2 gas and I2 gas, and they're reacting to form 2HI, and this is an equilibrium reaction where it's going to go both forwards and backwards, and the HI can break back up into H2 and I2 gases. Here is a chart that we're going to use typically to track the changes throughout an equilibrium. This is sometimes called an ICE chart, where the ICE stands for Initial Change Equilibrium. So with that in hand, what we can see we're given here is an initial concentration of 1 molarity. Remember, capital M is a short form for moles per liter. 1 molarity of H2 hydrogen gas, same of iodine gas, and no hydrogen iodide to start. And we're going to see, or we're given, that the amount of H2 gas is going to change by 0.2 molar, is going to decrease, and as a result we'll be left with 0.8 molar H2. Now if we look at our chemical reaction, we see we have a 1-to-1 ratio between the H2 and the I2, so if this decreases by 0.2, this will also decrease by 0.2, and as a result we will also have 0.8 molar, should be a capital M, molar I2. But here's the trick. Note that since if this is decreasing by 1, this is increased by 2, so if my H2 went down by some value of x, my 2HI would go up by some value of 2x. There's 2 of these for every one of these. And so if this is down 0.2, then this is 2 times 0.2, and so it's going to be up 0.4. So 0.2 that went away, 0.2 that went away, and it created 0.4 of that. Now my equilibrium equation puts my products over my reactants. So I have my HI over my H2 and my I2. I include all the species here because they're all gases. I don't have any solids or liquids. Nobody's fixed, so I include them all. And don't forget that my exponent here, 2, comes from the coefficient on the HI. And now, to get a value for K, for this equilibrium constant, we can use the actual given values. We should put our units in here because depending on the type of reaction, we will end up with actually different units for K. In this particular reaction, we have the same number of concentrations on the top as we have on the bottom, so all the molarities are going to cancel out. But they don't always, and we should pay attention because if they don't cancel out, our K values can be left with some unit in molarity. It could be molarity squared or 1 over molarity or whatever, depending on how the ratios work out here. So 0.4 squared divided by 0.8 divided by 0.8. And my K value for this is 0.25. And again, molar squared divided by molar divided by molar. They cancel out, but they won't always. So that is the value that the K would have in these conditions. Now these K values will depend on temperature, but they don't depend on initial concentrations. So if I had started with different amounts, this reaction would have worked out such that this K expression was the same regardless of which concentration I started with for the different products. So that's what it is for H2I2 at, I don't know, whatever. We'll just pretend our temperature here was like 25 degrees C. Changing the temperature, changing conditions like that can affect this K value.